钥匙管腰带，皮夹插后面口袋，黑光的眼睛有几千度，来变成西装裤，他不在乎，我却想哭，有点无助，他的样子像刚出炉的滚炉，他烤肉竟然会自带水壶，写信时用浆糊，走起路一不注意就撞树，我不想输，就算辛苦，我也要等，我也不能让你再走寻常路，我却比他熟。
The first defense against the heat is building huge embankments for the track. There are 1,000 kilometers of embankments on the Qinghai-Tibet Railway. The higher they are, the more they insulate the permafrost in summer. But they're more than just piles of rock and soil. Purpose-designed insulation panels make up one layer, but the most critical section is what's at the bottom of the embankment. A bed of crushed rocks, called plate stones, allows air to circulate between the railway bed and the permafrost.
The theory is that the spaces between the rocks are all connected, and it works like one seamless unit.
In summer, hot air rises and cooler air is trapped in the gaps between the stones, keeping the ground cool. Base is an effective low-tech solution, but it won't work for all unstable ground along the Qinghai-Tibet Railway. To keep more volatile permafrost cool, the engineering team found inspiration in the people who have been living in this land for thousands of years. To survive the constant bending and buckling of the ground, houses built on the plateau have simple but ingenious foundations.
This is a concrete ventilation pipe foundation. You can see the ventilation pipes all lined up. We could see something going on here. Look at the middle part of the house. It's not distorted at all, but at the end, it's cracked.
The railway engineers noticed that if foundation pipes on permafrost are ever blocked, the walls crack. The air gap insulates the ground from heat generated inside the building. As long as the pipes are clear, the permafrost does not melt and the house remains stable. Adopting the same time-tested strategy, the engineers installed ventilation pipes in the railway embankments as an effective and cheap way of keeping the permafrost cold. But for even more fragile zones, Professor Zhang and the railway's chief engineer, Zhao Shiyun, need a more high-tech plan.
We call this a heat pipe. These are heat radiation fins. So how does this device work?
The heat pipe is filled with liquid ammonia. It works like a refrigerator.
The air temperature can be over 10 or 20 degrees Celsius below zero. The ground temperature is only a few degrees below zero, and there is a temperature difference. The ground is warmer.
The warm soil turns the liquid ammonia at the bottom of the pipe into gas, and it rises inside the pipe. As the gas passes the radiation fins, the heat is released, and the ammonia cools and condenses back into liquid, then returns to the bottom of the pipe.
The heat pipe radiates the heat and cools the ground.
The heat pipes need no power supply. They're used on 32 kilometers.